Hello, I'm Carly McAvoy. I'm talking about graphing compound inequalities, and of course you'll encounter inequalities that you have to solve and then you have to graph them. Usually people do pretty well with solving inequalities and then they struggle a little bit with getting the graph correct. When you're graphing a compound inequality, it's important to notice whether you have an or an and statement. An or means it could be either this or that, right? So it's more like a union when you're talking about or. So let's look at the first graph. We don't have an equal sign, so we're going to have a parentheses. We're going to start at -2 and go to the right. For the second one, we're going to start at 3. We're going to have a bracket, and again, we're going to go to the right. So what we're going to do is combine these two graphs into our final answer because it's a compound inequality. So we're saying, what is these two? Well, if we combine them together, notice that somewhere around here would be 3, right? And so the -2 sort of supersedes the 3 because once you graph from -2 to infinity, you're covering that. So your final graph just looks like this. It looks like the -2 graph. We don't need to even show the 3 because it's understood. It's already in there. By going from -2 to infinity, you're already covering the 3 part. So your final graph just looks like this. We just need to show what the important number here, and anything 3, 5, 7, those are all expected to be in there. Okay, another or situation that you can have. Let's draw these two. We have x is greater than 3. That's rounded. It's going forever to the right. And we have x is less than or equal to -5. So we're at -5. We have an equal to part, so it's a bracket, and we're heading forever to the left. You should have graphed some inequalities before. This is just how to put them together. Notice that on our graph, we're going from 3 forever to the right, and we're going from -5 forever to the left. Those don't actually cross each other. If I put -5 and 3 on my graph, I'd have -5 over here, and I'd have 3 over there. So I'm going forever to the left from -5, and I'm going forever to the right from 3. Notice that I have the bracket at -5 because of the equal to part, and no bracket at 3. Now, because this is an or statement, this is what my final graph looks like. An or is a union, so we're saying, hey, x could be less than -5 or x could be greater than 3, either one. So we have the two parts on our graph. Let's look at the third one that I have here, another or situation. In this case, we have starting off, we have -1, and we have bracket going to the right. And the other one, we have 6, and we have a parentheses going to the left. Now notice what's happening here. We're going to infinity, from -1 to infinity, and from 6 back to -infinity. So when I graph these two, let me put both of these numbers on the graph. I don't really need to, but I want to show you what's happening. I have something that's going here, but I also have something that's going here. I've got the 6 going forever to the left and the -1 going forever to the right. So my final graph is actually just the number line. It's the whole thing, right? Because I'm covering the entire graph by going forever to the left and forever to the right. And when I combine those, I have -infinity to infinity is my final answer. Let me show you something about that. So this answer would look like this in interval notation. We're going to say the interval that this covers is actually everything, real numbers. And up here we would say we're going from -infinity up to -5. Remember, you always have parentheses at an infinity or -infinity. And then because it's an or statement, we're saying plus, which is a union symbol, we have 3 that going to infinity forever. So this one, there's 2 parts. There's going to be 2 parts in our statement. This one covers the whole thing. This one is just -2 to infinity. So the interval notations, remember, have to do with the parentheses and bracket, just like your picture. So since this has no equal to part, that's going to be parentheses. Infinities are always parentheses, and the only time you'd have a bracket is if you had an equal to part there. Okay, now let's look at some and statements. These are different. The and is asking you where do they intersect. So we couldn't have something like this that never intersect each other if we're talking about and. So if we have, let me graph these, I've got, remember intersection is like, going on a road, two roads meet. Where's that intersection? This one is going forever to the right from -2, and this one is going forever to the left from 5. This one has a parentheses, the other one had a bracket. So when I put those on the graph for an and statement, I want to know where do they actually overlap, or where is that intersection? So I know the intersection, because we're going forever to the left, we're intersecting up until we get to -2. -2 is going forever to the right. So the intersection here is from -2, and I'm including it because that's part of it, up to 5, but not including 5 because at 5 there's no intersection because it's not actually at 5, right? And so my intersection of those two is this. It's between those 2 points. And so the interval notation for that would be -2 up to 5. There's no infinity. It's not going forever. It's just going between those two numbers. And that's a really common and type of inequality. Let's look at another one. Let's say that I had this one. I am at 3. Sorry, that's a little sloppy. My paper moved unexpectedly. And then I have 1/2. It wasn't negative, just 1/2. And it goes forever to the right. What I want you to see is, again, we have -3 going forever, 1/2 going to the right. I think I meant to do something different there, but what I actually did here was I'm starting at 1/2 and I'm ending at 3. And here we have equal 2 parts on both ends, so we would have this. From 1/2 I'm going to the right, from 3 I'm going to the left, and again I get this in here. And then this example, I have y is less than -2/3. So, no, it's greater than -2/3. So it's parentheses and going to the right. And then y is greater than 0, and that's also going to the right. So I want to know, where do I actually overlap? Well, we're starting in the negatives and we're heading to the right, so we overlap starting at 0. So my final graph for this one would be, I'm starting at -2/3, but I don't overlap there, so I'm starting at 0 is when I start to overlap. So I have the 0 to infinity. That's all I have, because the overlap back here where -2 up, -2/3 up to 0, there wasn't an intersection there. So my final answer is just this one. And the last one I want to show you is, what if I have y is less than or equal to -1 and y is greater than 4? This is an and statement. So I want to know, where's the intersection? Look at these two graphs. I have -1 and I'm going forever to the left, and I have y and I'm going forever to the right. But those two things never overlap, because if I put those on the same graph, I can see I've got -1 heading that way, and I've got 4 heading this way. If this was an or statement, that would be fine, but this is an and statement saying, where do they intersect? They never intersect, so the answer is no solution. There is no intersection for that. We just say there's no solution, because there's no time when y is less than -1 and at the same time greater than 4. So that would be it. So those are all the different graphing situations that I think you're going to encounter. All right, have a fantastic day.